This is section 5.3, multiplying and dividing monomials and negative exponents. First of all, let's define a monomial. Mono means one. So monomial is a single term. A term is made up of numbers and or variables tied together by multiplication division, but separated by addition and subtraction. So it's when you see the addition and subtraction sign that you actually know that the term has ended. These are some examples. Negative 5x, 3x squared y, 4/3 a squared, and negative 5ab squared c divided by 2xy. Now each of these are terms because none of them are separated by plus or minus signs, and they are made up of variables and or numbers. And xy squared. All right, the coefficient is the number that comes before the variable in a variable term. Take a minute and circle all the the coefficients in the monomials listed above. All right, now check your work. Negative 5, positive 3. Next one's tricky. 4/3. Even trickier. Negative 5 halves. And for xy squared, it's there, it's just not written, and that would be positive 1. All right, state whether the following is a monomial or not. Turn off the recorder, stop the tape, and answer the next couple questions and let us know if these are a monomial. All right, now check your work. Monomial because it's a number. Not a monomial because this is made up of two terms, not one. The plus sign separates the terms. I have a variable term, and the 5 is what we call a constant. Number 3 is a monomial. Number 4 is a monomial. Number 5 is a monomial. Number 6 is not a monomial because it's made up of 3 terms. Number 7 is a monomial. And number 8 is not a monomial. All right, now we're going to go back and do some review and multiply our common bases. Remember the rule for multiplying common bases is that if they have the same base, the shortcut is to add the exponents. So we multiply coefficients and we add the exponents. So let's do number 1 together. Number 1, coefficients we'd multiply would be 3 times negative 2. And the variables we would multiply would be a squared times a squared, or a squared plus the second squared power. This simplifies to negative 6a to the 4th power. Now stop the recording and you finish the next 3 problems. All right, now check your work. Three times 5 times x to the 1st power plus the 4th power is 15x to the 5th power. Negative 4 times 3 times negative 1 is 12 plus m squared times m squared plus m to the 4th plus the 1st makes 12. m to the 7th power. Number 4 is going to be 21 a to the 5th, b to the 3rd, c to the 4th. All right, now we're adding two rules together, common base and power to power. So when we have power to a power and common bases, first we take care of our power to power rule. So I would square everything in the first parenthesis, so that means 5 is squared, and y to the 3rd times the 2nd power. In the second parenthesis, I'm going to do the same. Everything is to the 2nd power, negative 2 is squared, y squared is squared. This simplifies to 25 y to the 6 times 4 y to the 4th. Simplify it further. 25 times 4, multiply the coefficients, is 100 y to the 10th. Now you do the next one. Okay, now check your work. 3 squared times c squared, negative 2 to the 3rd power times c to the 4th power times the 3rd power simplifies to 9c squared times negative 8 c to the 12th. Simplify further by making it negative 72 c to the 14th. All right, I'm going to veer off from PowerPoint right now. I'll show you the PowerPoint's method, but you don't have to use it. I like to use a different method. So, just a reminder, multiplying common bases. When we are multiplying common bases, we add the exponents. So we can continue to use our same rules. 3 to the 4th power plus the negative 2 power. So I'm adding both exponents. Makes 3 to the 2nd power, which is 9. When dividing common bases with negative exponents, remember we subtract. So I take the top and subtract the bottom is the shortcut. So the top is negative 2 minus the bottom is the 3rd power. So the shortcut would be 7 to the negative 5th power. Now remember, negative exponents are really fractional amounts. So we take the inverse of 7, which is 1/7, and we take it to the positive 5th power once we put it into fraction form. 7 to the 5th power. 1 over 7 to the 5th power. So I personally prefer to take the inverse almost right away. Alright, so here's where I'm going to veer off and show you my own method. So if I have x to the 5th over x to the negative 4th, first thing I do when I see a negative exponent is that I am going to take its reciprocal. So since a to the negative 4th is in the denominator, I'm going to move it up to the numerator and I have my x to the 5th, and then I'm going to also move that x to the 4th, and I'm going to take the positive version of it. And what's left in the denominator when I move it out is a 1. So this really makes x to the 9th. Okay, take a minute, write that down, because I'm about to erase this and show you how my PowerPoint does it. Okay, now I can do the subtraction method and take x to the 5th power minus the negative 4th power, which gives me x to the 9th. Now you try the next one. You may use either method. Stop the recording. All right, now let's check your work. Oh, wait, sorry. Let's go back. So anyways, what the PowerPoint was also showing below is when I have x to the 5th, it really means divided by the fractional amount 1 over x to the 4th. Well, this is what we call a superfraction. So to write it in a clearer way, we write x to the 5th divided by 1 over x to the 4th. And if you remember from dividing fractions, we don't divide fractions, we multiply by the reciprocal. So again, I'm going to have to take the reciprocal, which is pretty much what I did in the beginning. My method, take the reciprocal right away. All right, now check your work on number 2. And I'll show you my method. My method would have been, if I do it in blue, all right, I would have taken y to the 4th, and it's really basically what it is on the bottom. Since it's times y to the negative 3, I would have written it y to the 4th over y to the 3rd. Then I'm going to divide out 3 y's out of the denominator and 3 y's out of the numerator, and I'm left with 1 y in the numerator, which is equal to y. All right, let's move on. All right, take a minute and let's divide the monomials. Now I'm going to do number 2 with you, and then I'll give you a chance to do number 1 and 3. All right, so think about monomials. When you have terms like this, you really have 2 problems. You have variable problem and you have a fraction problem that we're using for the coefficients. So what number can I divide out of both 8 and 2? What common factor? Oops, sorry about that. What common factor can I divide out of 8 and 2? That would be 2. So when I divide 2 by 2, I'm left with 1. When I divide 8 by 2, I'm left with 4. What common factor can we divide out of the numerator and denominator in terms of the x's? I can take a total or divide out a total of 4 x's out of the numerator and denominator. It has to be the same amount. In the denominator, I'm left with 1. In the numerator, when I divide out 4 x's, I'm left with x to the 5th. So now I'm left with 4x to the 5th over 1, which equals x, 4x to the 5th. All right, now pause the recording and you do number 1 and number 3. Go. All right, now let's check our work. In number 1, I can divide out the same amount of a's that I can divide out of the numerator denominator is a to the 3rd. So in the denominator, I'm left with 1. a to the 3rd divided by a to the 3rd is 1. And in the numerator, I'm left with a to the 7th. So this simplifies to a to the 7th. I don't know if that's any better. All right, number 3. I can divide out a common factor of 3. I'm left with 2 and 3. I can divide out a total of 4 m's, and I'm left with times 1. And here I'm left with m to the 8th. So this simplifies to 2 over 3m to the 8th. All right, erasing. The PowerPoint uses the subtraction method. I find it easier to just cancel out in the fraction because our fractions will get bigger. All right, take another minute, put the player on pause, and continue. All right, now check your work for 4, 5, and 6. At this point, I'm going to let you just check your answers. Should have ended up with x to the 5th over y to the 3rd for number 4. Number 5 is 2a to the 5th, b to the 0, which simplifies to 2a to the 5th. I better go back. Last one, number 6, is 4 over 5w to the 3rd x squared. All right. Power to the power with negative exponents. Remember, when we have a power to the power, we multiply the exponents. Okay, so I'm doing the same thing. 2 to the 3rd power times the negative 2 power makes 2 to the negative 6 power, which is 1 over 2 to the 6th power. Remember, it's a fractional amount. Now you can take the reciprocal in the end, or other alternative is right away when you have 2 to the 3rd power all to the negative 2 power. You could drop it down right away, the entire parenthesis, 2 to the 3rd power, and square it. Simplifies to 1 over 2 to the 6th power. Now this is pretty reasonable. 2 to the, we can multiply this out in our head. 2 to the 5th power is 32, so 2 to the 6th power would be 64. Okay. 1 over 64, sorry. All right, now you try it. Let's look at one more example. So when I have 8 to the negative 2 power, I drop it down right away, take the reciprocal, and I get 1 over 64. So they're working inside out using more of the order of operations. So we do the parenthesis first. Inside the parenthesis, we do the exponent. Then I take it to the negative 2 and take the reciprocal. So there's a lot of different ways to do these. You just have to find a method that works best for you. All right, so let's do the first 2 together. I think this one's easy enough that I can just do the subtracting method. So I would probably do on number 1, 5 to the 4th power plus, because they're multiplying, we're adding negative 2. So 5 to the 4th power plus negative 2, which makes 5 to the 4th minus 2, which is 5 squared, and that simplifies to 25. Again, number 2, you have an option. So I think right away, I'm going to take and drop this down into fraction form. And put this as 1 over 8 squared, which equals 1 over 64. Okay. It's only to the first power, so I don't really need to write that. All right, now stop the recording and you practice the next few. Okay, now check your work. Number 2 is 1 over 64. Number 3 is 1/7. 4 is 1/3. 5 is 8 over 25. Number 6, don't forget about that 4 to the first power. Even though it's not written, it's there. And then that is multiplied by the negative 2 power. It's the positive 4th power. So it's 256. All right. Now I have a monomial, and I want to remind you the base of that exponent is only what it's touching. So in this case, in number 1, it's only touching the m. So the m is the only part of that monomial that actually drops down into the denominator to the 2nd power, and the 3 stays in the numerator. I'm going to jump down to number 6. Number 6, okay? Since the parenthesis is touching the exponent, everything in the parenthesis drops down into the denominator and is to the 2nd power. So this makes 1 over 36. Remember, x is squared and y is squared. All right, you continue, stop the recording, and do 2, 4, 5, and 6. All right, now check your work. Number 2 is 6x over y squared. Number 3 is 1 over 6xy. Well, actually, it simplifies. We've already done this one. 1 over 36x squared y squared. Number 4 is 1. That's my dog. Number 5 is 1 over 8x to the 3rd, y to the 9th. And number 6 is 4 over a to the 6th, b to the 4th. All right, negative exponents in the denominator. And this is the reason why I just get rid of the negative exponents in the beginning, because when they're in the denominator, it gets a little confusing. This looks pretty lengthy, so I think I'll veer off from the PowerPoint and show you. So 3, when I have x squared to the negative 2 power in the denominator, remember I take the reciprocal. So that means instead of it being here in the denominator, I'm going to move it up to the numerator, the reciprocal. So now I'm going to have 3x squared over 1, which equals 3x squared. Okay? I think that's a little bit easier. Let's see what my PowerPoint does. They do exactly that. All right, now you try 1, 2, 3, and 4. I want you to write these without using negative exponents. All right, now check your work. And that's our lesson for today.